Hey everyone, I just want to give a very quick disclaimer before the start of the episode that this episode was recorded in January of 2020. Now, the reason why I say that is because at one point in the episode I mentioned doing weekly Japanese lessons at my house, and that was accurate months ago, but it is no longer accurate due to COVID-19. So just FYI, we are practicing social distancing and all that. Anyways, I hope you really enjoy this episode, and let's get it started. Welcome back to another episode of the CS K8 podcast. My name is Jared O'Leary. In this week's episode, I'm interviewing Andreas Stefik. In our discussion, we talk about the importance of using evidence-based programming languages. In particular, we talk about it in relation to designing for accessibility for kids with disabilities. We also talk about some of the problems with the lack of replication in CS education scholarship, as well as some of the problems in academia in general. In addition, we discuss an evidence-based programming language that Stefik helped create that's called Quorum, as well as many other topics relevant to CS educators. There are a good amount of show notes that link to many of the papers that we've discussed, as well as some other music-related concepts that we discussed at the beginning and towards the end of the interview, as well as many resources that can help with designing for accessibility in your CS classroom. You can find those show notes by clicking the link in the app that you're listening to this on, or by visiting jaredoleary.com. And we will now begin this entertaining and informative interview with an introduction by Stefik.
My name is Andreas Stefik. Almost everyone calls me Stefik. I'm a computer scientist that works at the University of Nevada, Las Vegas. I do a lot of work related to two major things. One is investigating how people invent things in software, sort of investigating programming languages. But I also do a considerable amount of work related to how people with disabilities do computer science. I invent a lot of stuff in that direction.
Can you tell me the story of how you got into CS education and research?
When I was an undergraduate, I was doing a degree in music. I've played in bands for years and stuff. I was never really very good at it, but I enjoyed it. You know, it was kind of a fun, like, hobby type of thing. And I was reading in textbooks at school on this composer named Ben Johnston. He did a lot of music that's called microtonal. It's kind of like keys between the keys type of stuff. Frequency bands not on the piano that could be used as notes. And that always sounds wacky when you say it, but actually there's really good reasons for it. That's because some notes on the piano would actually be more in tune and others are actually less in tune. And you can figure that out using some pretty simple math. In any case, so as an undergrad, I moved to the East Coast to work with this guy. And when I was there, he was using a lot of music notations to represent this kind of music, inevitably kind of complicated, that were really hard to understand. And there was a string quartet called the Kepler Quartet that wanted to play the music, but they couldn't figure out what it would sound like based on the notation. So the problem was the notation was really hard to understand. They wanted to play it, but they really couldn't do it. So this guy, Ben Johnston, he sort of asked me when I left the training to see if I could figure out an alternative that would make it easier for groups to play as a notation. So I started taking classes in computer science, thinking maybe I could write a computer program or something, or do some kind of math or some funny thing to make it easier. And it took a couple of years. And by the time I had figured it out, I had a computer science degree. Eventually, though, a number of albums were produced on this, and I kind of moved forward. But by graduate school, I had already done all this stuff related to notation to try to make it easier to understand. In addition, I'd been doing music since forever. So I was trying to think of projects related to who benefits from sound-based technologies in computer science. So I started talking to schools for the blind, and just talking to their kids. Hey, kid, have you ever written a program before? Do you want to try? And then kind of watching them and inevitably watching them struggle, because doing programming when you're blind using off-the-shelf technology can be a pretty serious challenge. And everything kind of snowballed from there in terms of my interest into computer science education.
Now, was the notation that he was writing, was it aleatoric, so like chance-based, or was it, no, this is a very specific note that I want you to play, but it's in between what's typically the white and black keys?
It's the second one. So
okay.
Aleatoric, you're thinking of like John Cage's style notations?
Yeah, it's more like graphical, where it's kind of like up to the artist's interpretation, like how do I play this thing?
Yeah, actually funny, if I recall correctly, I think John Cage lived in Ben's attic.
Huh.
I think that's true. In any case, no, it wasn't aleatoric, but he was influenced by that kind of stuff. So there are some things that kind of sound chancy in his music, but it's very specified. So for example, if you had a particular note combination, you actually specify mathematically the relationship between the two notes. So like D to A is exactly the frequency of D multiplied by 3 divided by 2. right? That's not a key on the keyboard.
Right.
But in his notation, that would end up with a certain set of symbols that represent that frequency relationship, not the normal keyboard. And it has all these weird names like syntonic commas and stuff like that. And it gets kind of wacky. But what's interesting about it is it actually explains, when you're thinking about choirs and stuff, why choirs tend to go flat and sharp over time, because the frequency bands on a piano don't actually match what would be in tune. And so it kind of like is somewhat explanatory. It's sort of fascinating.
Yeah, and if this is too abstract for people who don't have a background in music, I'll include some resources in the show notes that kind of explain the different types of tunings and whatnot that you can find. Could you elaborate on what you mentioned with watching a blind student try and code? What did that look like in terms of your ahas and going, oh, this is not at all how somebody who is able to see uses this program?
I'd kind of been primed with the challenges related to notation, as I kind of mentioned. Now, it's a totally different kind of notation, but nonetheless, that was clear in my head. So I called the Washington State School for the Blind and I was like, hey, I want to do something together. And then eventually, after some grants and some stuff like that, I went and we started observing kids. And so one of the very first things we did some experiments where we had kids in that age try different programming languages and literally just try them, like write a loop, write a this, just simple little programs. And because they come out through screen readers, there's weird things that happen, right? At least weird if you're not a screen reader user, which I usually explain because most people aren't. And so I'll give you an example. You write a loop in C++, you can see it visually if you know the code. What it sounds like is for left paren, int I equals 0, semicolon, I less than 10, semicolon, I plus plus right paren left brace. Now imagine hearing that as a 14-year-old kid 3 times faster than what I just said and not knowing what a single symbol meant, right? All of a sudden that's tricky. And then if you have an error in your code, you're going to get a compiler error back. Now, in an IDE, a development environment, you might have like a little visual display on the bottom of the screen, and your eyes, you naturally skip certain things. So like Microsoft's Visual Studio at the time, it would have like all sorts of weird error codes, colons, funny slashes, and stuff like that. And when I visually look at it with my eyes, I skip stuff, right? I'm not going to read underscore CCEDCL : 4585. That stuff is just useless.
Right.
But if you're listening with a screen reader, guess what? Every character gets read. So you got a compiler error. That compiler might last a minute in audio, and the actual thing you did wrong, like, oh, you missed a semicolon, is like halfway through. So it's real easy to miss. So when I was sitting there watching this, and I was like, man, there's no way that someone like maliciously designed it this way. I bet just no one cared and even thought about for a moment whether this would be a good design for somebody that's using a screen reader. So that smelled like an opportunity, and we kind of jumped on it.
So how's your research in accessible computing kind of informed your own practices as an educator and a scholar?
One of the first things that we thought was when we were watching blind students, well, babe, this is probably just a blindness issue, right? I skip over that stuff. I don't need it. Or maybe for left paren, all that kind of stuff, it doesn't really matter. But it turns out that we were suspicious that that was probably wrong. Why is it that programming language designers use the word for? And it's not just like C++. There's kids' languages too. Pencil code uses the word for. That's a block language. It doesn't really matter. Like lots of language designers made decisions about how they represent their code. I wonder, what is the data? Like, when C++ was made, like what kind of evidence did they use to make their decisions? Or like, Python's much newer. What is the evidence on various decisions that they made in Python? Like what's the evidence on the white space? What about the colons? All the other funny things. And so I like kind of naively thought, well, let's just go look it up and gather all the data that the language designers have been gathering and try to figure out like what was the right answer so that maybe we can make it a little easier for these kids. What I wasn't expecting was that there wasn't any data. And that language designers have, in fact, emphatically been against gathering data, and I'm not kidding about that, for a long time. And this intuition that like this sort of like it's not part of their community gathering evidence is really weird sounding. So people that like aren't used to this idea that scientific communities also have their flaws and imperfections, this has actually been formalized by a number of scholars. One of them is there's a guy named Antti Juhani Kajana, who's this Finnish scholar, and he actually analyzed effectively every paper from like 1950 till 2012. This is like peer-reviewed, top conferences, made decisions about National Science Foundation support, all sorts of stuff. And it turns out between that entire 60-year time period, there was 22 experiments.
Wow.
And that is nuts. absolutely nuts. Like that just should not be true. When people are designing programming languages, there's two parts. There's the technical, you got to make sure that it works, and then people have to use the damn thing. That's a fact. We all do it, and developers get paid an enormous amount of money nationwide or worldwide to use these things. Hundreds of billions of dollars a year gets paid to devs. So tiny little impacts in productivity impact billions of dollars nationally. It's a big deal.
And is that including even just like quasi-experimental or?
Yeah, so whenever you talk about gathering data, how you gather it depends a lot on the context under which you're gathering. So for example, the word you use, quasi-experimental, often means that you lack certain methodological controls in an experiment, but sometimes you have no choice. You actually have to do that. For example, I can't give half of the country cancer, right? That doesn't make sense.
I don't think it'd pass IRB either.
Yeah, I think the ethics board might have an issue with it, like just plausibly, right? Just on a practical level in education, this is a big deal too, because even though it's much less extreme, I can't take kids and randomly assign them to schools that are at various levels of poverty. I can't randomly assign them to new parents or stuff like that. So there's always an element of, in the field, you have to make certain compromises when you're conducting studies, and there's no choice about that. Even if you really wanted to, it would be impossible to do otherwise. On the other hand, it's full experiments, and there's surveys and stuff like that too. Full experiments where you do have custom controls, those have value too. You just use them for different kinds of things when you're looking for evidence. So we kind of do a combination of things, and that's really common.
Yeah, and in education, for people who don't have a background in research, it's particularly difficult to do full experimental studies. One, it tends to make things decontextualized, like you might be going to a lab setting rather than a social setting where kids are learning. But the quasi side of things, you have a lot of factors and variables that you can't control for because you're in a live setting where kids are learning, not just in the environment that you are testing in.
Yeah, so I think that the model that I like the most, and you may not like this particular model, I don't know. There's a very famous scholar named Austin Bradford Hill. You ever heard of this guy?
Mm-mm.
You know the phrase that smoking causes cancer? You know this?
Yeah.
I mean, it's commonly known. Not everybody buys it, I guess, but the evidence is very clear, right? That's Austin Bradford Hill. He was basically the first scholar to sort of show pretty definitive evidence that smoking not is correlated with cancer, not might be related to cancer, but no, it causes cancer, right? And the way that worked, what's called medical randomized controlled trial. Now, when people say that word, randomized controlled trial, they think it's a custom experiment that just had very careful controls and all sorts of stuff like that. But actually, since Bradford Hill, experiments, even in other disciplines where you have these constraints, just like you do in computer science education, they use a combination of what can we control and what can't we, and then how do we correlate with other factors. So I'll give you an example. In some of the original studies, they would do things like, okay, I know that I can't give people the cancer, and I know I can't control their smoking habits, so I can't control for that, but I can control for certain other kinds of things. And so they would basically design these studies where they had control groups, and they did it for certain things that they cared about that they can manipulate. And then there was other things that they basically just tracked anything related to it so that they could correlate it in and rule out alternative explanations. So when we conduct studies, although nothing's perfect, you have to just kind of do the best you can, we always try to follow the Bradford Hill model, where it's like, control what we can control, and then correlate in any other factor that we can so we can at least get clues about causality.
Yeah, and then I'm assuming doing follow-up studies to kind of like re-verify in different scenarios and with different participants and whatnot.
Follow-up studies, replications, you want other groups to do it in a different way. You want people to vary the experiments. Science is complicated and you want all that stuff.
One of the guests that I spoke with had mentioned that was one of the biggest things that she wished there was more of, was people following up and doing studies with different sets of people and whatnot, just to kind of find out, okay, well, we thought this thing, but now when we applied it in this different context, we ended up with a different result. And so let's explore that and why. In general, not a lot of replication going on in the field of education.
Yeah, and there's a couple reasons why that is, actually. And one of them is that, especially in computer science education, it sounds really weird to say, but we actually have no evidence standard. Now, what does that mean? Well, actually, it turns out there's a formal thing called an evidence standard. It's not like a term I'm making up. It's like a standard term, evidence standard. And what it means is that when you publish papers, there's certain protocols you follow for how you report experiments. Now, think about this. If I'm in the medical journals, they actually follow one called CONSORT, CONSORT. CONSORT is a medical standard that you have to follow if you publish at certain journals. And it basically means that you have a replication packet. You have certain things you report. You report demographics. You report how the study was done, that kind of stuff. And the reason that matters is because anybody that wants to replicate it really needs that information and able to do it. In education, there is a evidence standard called the What Works Clearinghouse. It's much more complicated, and that's a whole other topic of discussion. But it's not really the same. And when you talk about computer science journals, the evidence standard they use is nothing. People just kind of publish whatever they want. So if you want to replicate other people's work, sometimes it's almost impossible because you really don't have the information you need, let alone like a replication packet and stuff like that. So it makes it really tough because our journals haven't kind of gotten on the bandwagon yet for evidence standards, and therefore we're really behind.
Yeah, and I've done some reviews for the Department of Ed and then applied for some grants that required What Works Clearinghouse. And the problem that we were running into was there weren't any studies related to CS education that we could cite. So what we ended up doing was saying, well, here's some professional development stuff that's in alignment with what we're doing, but it's in a different content area. So it's kind of like this, but not really.
I 100% understand exactly what you're saying. That's completely true. Because we don't follow the standards, then it is what it is. And it's tricky too. Computer science education is also an international community. It's not just Americans. But the What Works Clearinghouse only covers Americans. So it's sort of funny, like we almost, in a way, want like an international evidence standard that covers everybody. Because like, are the kids in Finland the same as the United States? Maybe, but like, maybe not. And in fact, there's some evidence to suggest that that's not true. There's a woman named Felina Hermans that does really fantastic computer science education work. I think she's in the Netherlands, and like they speak a different language. And the programming languages are in English. What are the challenges there? Well, they're not zero, right? They're complicated.
Right.
You know? But yet that's not going to make it into the What Works Clearinghouse, even if it's solid work.
Right. Yeah, hopefully in a couple of years that'll change. But
I hope so too. Yeah.
For now, it's just frustrating.
It is frustrating, right? Well, plus, like, it's so much easier to read studies that are in an evidence standard. Like, you look up a study on PubMed that follows Consort, you know where everything is. Like, oh, you want to look at demographics? Well, it's in the section with that exact name every single time. There's no debate. It's just simple.
Yeah, for my dissertation, I tried to make it as replicable as possible. So it was a corpus-assisted discourse analysis. So I looked at like 11 million words of data and tried to find patterns of discourse. And then what does this mean for education? So like in my methods chapter, in chapter 3, it was just all about, okay, if somebody else wanted to be able to redo this study, what do I need to include in there? So I was very conscious of that. So hopefully people could redo it if they wanted to.
Oh, that's lovely. 10 years ago, we had replication packets, but they were all kind of like, we didn't really know what they should be and stuff. Nowadays, replication packets are download this on GitHub, add humans, right?
Right.
And so it's a lot, at least theoretically, a lot easier to sort of replicate the studies. Now, does anybody actually replicate our studies? I kind of doubt it, but it's possible. And that's the first step.
Yeah, then there's also the issue of, well, what counts in terms of publication and for the institutions that you're at? Like, are you going to get as many citations if you're the one doing the follow-up study or if you're doing the initial study that people are then going to try and replicate?
That's a good point. I mean, like we obsess about these ridiculous things like H-index and citation count.
Right.
I mean, they're not totally dumb. Like we do care about it to an extent of like, you know, you want your work to be used by other people, but it misses two fundamental things, like these kind of weird metrics that we're obsessed with in academia. Number one is all the metrics related to citation counts and paper writing and stuff, they usually emphasize that you should be writing, right? Like your H-index. How do you get your H-index up? You write more papers, and then you write papers in popular areas. That's it, right? That's the most likely way to do it. So pick a big community and then write lots of papers to that community to increase your H-index. However, we forget that as computer scientists, we also can invent things, and that has value. So for example, we invented this programming language called Quorum, and it's used last year by, I think, like 81,000 people. Right now, that's a metric. But at the same time, like, if I spend time writing that application, I'm actually not spending time writing, which might look bad from other academics' perspective. But honestly, I don't care because I think that has more tangible impact on society than just obsessively working on writing only. So it feels like we need, as a culture of academics, we need a better balance as to like how we think about what we choose to do in our own jobs. So.
Well, and it rewards and kind of punishes some approaches over others. So, for instance, survey, really easy to send that stuff out and to get data back. But doing a longitudinal ethnographic study on a particular culture or set of people or whatever, that's going to take much more time. And it might be multiple years until you can actually start publishing on the actual findings from those kind of studies.
Well, 100%. The first big study that we did on programming language design was in 2013. And it took my student and I 4 years to put that study together. Now, that's not woe is me. It took a long time. That's because we wanted to know the answer.
Right.
Does that mean that I could have been doing smaller studies or split them up into little mini papers and it's just so stupid. It's just a waste of time. It's easier for the research community if we have one resource that's well vetted over a long period of time than lots of little mini pubs that get tossed out all the time. This is sort of, I don't know, I just feel like we waste, because we're so obsessed with these metrics, it also wastes our time because we end up reading the next increment on the same paper, which is a 3% improvement on this algorithm or something, instead of waiting a couple years and getting a big foundational advance.
So I'm curious, what's something that you believed about accessibility in particular when you first began, but you no longer believe now that you've done some research in that area?
When I first started working in accessibility, I was working only with blind people. Now, that's not true anymore. We work with deaf people, blind people, people with mobility impairments, learning disabilities, all sorts of stuff. And I love it. I love every minute of it. But when I first started out working only with blind people, I didn't have context for all these other groups yet. And so I sort of naively, I think, assumed that when you add support for one group for accessibility, that mostly impacts that group. But I know with certainty that is not true, and I'll give you a few examples. If you have people that are blind or visually impaired, they use the keyboard very heavily because you can't see the screen. You wouldn't use a mouse. That makes no sense, right? I mean, some people that are blind can also see. That's complicated, but never mind that. I even have a student that is blind, legally blind, but can drive, but never mind that. Depends on the state. And since they're using the keyboard heavily, because they're very used to it, if the keyboard shortcuts are really nasty, it will get very annoying very fast. So if you're blind, it's important to be able to remap keys to sort of whatever is kind of convenient to make sure they follow standards, don't conflict with screen reader keys and stuff like that. However, if you have a mobility impairment, you must be able to remap the keys. You just have to, otherwise you really can't use the product. In addition, you might think that if you have closed captioning for a video, that only impacts the deaf. But actually, that's not true at all. And it impacts parents. If you have closed captioning and you want to turn the sound off because your little kids are asleep, you might want to read it. Or if you're in a hotel or something, or at an airport or whatever it is. In addition, people that are blind often download closed captions so they can read the transcript with their screen reader at higher speed. Because waiting for the video can sometimes be very slow, and there might be visual things on screen that don't get shown except maybe in the captions or somewhere else.
Interesting.
Yeah, so a lot of the technologies that you use that are related to disabilities often get used not just by that group, but by other disabilities groups that end up having the same reliance, but also groups that you wouldn't think of, like a parent that just has a screaming kid, or someone in a wheelchair that has a curb cut that they go up. Well, that's going to be used by a woman with a stroller too that has a child. So I think that even though I'd heard these phrases like curb cuts before when I was doing accessibility research, I think that message didn't really hit home until later when I was sitting watching different kinds of groups, like watching a kid with dyslexia use a screen reader and things like that.
So what is something that you wish more CS educators kind of understood about accessible computing?
There's really two things that I often think about that went with accessible computing for computer science educators. Number one, I wish more people realized that it's required by law. So for example, if you're developing a tool, you're making blocks or something like that, right? You are putting yourself at legal liability if you don't add accessibility support in K through 12. That's never fun to say. That's the not nice thing about accessibility. But actually, there's laws protecting people with disabilities because they've been horribly discriminated against historically. For example, if someone said, I'm going to have a child with darker skin excluded from this computer science curriculum, all of us would flip out, right? That's just unacceptable. Or if you said, I don't think women should be programmers, we would say, screw you. That's just completely unacceptable. That's just not right. But if almost every single block language out there is inaccessible to the blind, we sort of throw our hands up and say, well, it is what it is. So number one, the not nice thing about accessibility, but I wish people knew more, it's required by law. It is not optional. In K through 12, every child has the legal right to do education. As states increasingly make computer science mandatory, people are going to have to cope with that. But the second thing that I think that is much nicer about accessibility is that like people with disabilities often have observations about how they invent things that are super fascinating. Like watch it. I would not have realized that you can make progress on a problem as complex as the programming language wars, like how, these languages vary and whether they're easy or hard has been a matter of debate for a long time until I started watching blind children. I just wouldn't have noticed because I didn't think about it. I'm so used to, these looping structures and classes and all this kind of stuff. I wouldn't have thought about it. So oftentimes when you work with people with disabilities, you get the big advantage that you get to observe things that many of your colleagues in computer science education would not have seen.
Right.
You get to see them like, trying to program with audio and seeing all the shortcuts they press. Or you get to see someone with deafness trying to interpret some really bad captions in a funny way. Or looking at the language differences people that are deaf have in comparison to people that weren't using ASL for most of their life. Or watching someone with a mobility impairment try to get around some particular feature that they're using. I mean, it's fascinating and has a lot of opportunities for making things easier for everybody. And like, I feel lucky that I get to kind of sit and observe these people all the time, that they kind of allow me to do that because it gives me a lot of fun insights that I get to come back and play with.
Yeah, I think that really speaks to having diverse teams and having diverse users, whether it be in beta testing or product users or whatever. I was at WWDC in, 2016? And paraphrasing here, one of the things that they had announced at the conference was that their approach was focusing on designing for the margins, so that way you can include everybody, whereas if you design for the average, then you're excluding the margins and whatnot. And that really kind of hit home for me, where it's just like, oh yeah, that makes a whole lot of sense. And they showcased it by having like blind DJs go up and perform and like things like that. Just like little things that are just like, okay, this is really cool. And it's nice to see that one of the largest companies in the world is really pushing for making things more accessible for people.
I think Apple has put in a lot more work than a lot of groups. And I think it's gotten better over the years. Nothing's perfect at any company. And even with really good intentions and stuff like that, sometimes the challenges can be hard to make something accessible. It's not like you flip a switch. It can be difficult.
Right. So speaking of that, what might you recommend for CS educators who are kind of designing either like curricula or educational experiences? What would you have them consider to become more accessible with the experiences or curricula that they use?
Yeah, so there's a few things. Number one is for the curriculum itself, when it comes to like, the text that you write and stuff like that, always at least do the basics. Basically understand that web browsers do a pretty good job for accessibility. They're really not that bad, but you have to not break it. So like, I'll give you some examples of ways that you could break it, usually not maliciously, that are kind of adorable, that I think are funny. So my daughter right now is, at the time of this recording, is 7 years old, and she goes to a local school. And at their local school, they have a calendar that like just kind of says their events and stuff like that. And like, it's clear they don't have an expert putting their website together, which is normal. It's a grade school, right?
Right.
And so and this is so adorable. They actually have like, it's like I don't know if it's like a spreadsheet or what, but they like take a picture of it and then they put up the picture. That's it. And like, as a computer scientist, I look at that and I'm like, oh dearie, that's just not. But here's the thing, it's not malicious. They're just like trying to put up the schedule for everybody to look at. You don't do stuff like that. Like, don't like take pictures of text and just put it up with an alt or something like that. That's just a really bad idea. So use text normally and that kind of thing. And the second thing is, when you do have pictures, there's nothing wrong with that, but there's little tags you have to put in that are called alts that give you descriptions and things like that. And those kind of things are really like the bare bones basics of making sure that stuff is accessible. They don't make your site accessible. They don't make your tools accessible, nothing like that. But it's like, if you don't do at least those things, things are probably broken for many kinds of people. I want people to do more is to start making sure that when you're writing grants and when you're using tools, make sure everything in your tool chain is accessible. And just like, if something in your chain isn't accessible, drop it, get rid of it. Use another technology that is accessible, because it is the law and also because it's the right thing to do, And there are challenges there. Like, I think that we can make block languages accessible over time. I think that will be solved. I think that that's not like a huge technical burden. I think that's okay. And I also think that there are technical challenges that people have as they're doing stuff. Like if you're making a curriculum related to Android, well, Android naturally has some nasty accessibility stuff in it because the Android accessibility architecture is really not that. It has issues, right? And then vice versa, like accessibility for every platform, it turns out, is very different. So Apple's accessibility architecture is 100% incompatible with the Windows one, which is 100% incompatible with the Android one, which is 100% incompatible with the web. So cool, great job. So to a certain extent, I feel empathy for many curriculum designers because they're like, well, I really want to use platform X. I don't know about accessibility on that platform, and it's complicated, and I need help. So the one other thing I would mention, if you are someone that does curriculum and you don't have the expertise to do it, reach out to those of us that do, because we can totally help you. We have grants to help you, and we have like thoughts about it. We can go through it with you and talk to you about it and go through some of that stuff. It can be complicated sometimes depending on the platform, but that's reality of the nature of accessibility today.
So speaking of platforms, you had mentioned Quorum already. I'm wondering if you could describe what Quorum is for people who aren't familiar with it.
Yeah, so Quorum is a programming language. So I mentioned this issue of like evidence with language design. So my lab and I thought, well, if you were to try to make a programming product based on evidence, what would that even mean and what would that be? So Quorum has become a programming language where we meticulously and rigorously and sometimes even obsessively go through every symbol, every character, every combination of semantics and whatever with human studies to try to make it easier to understand. And there's two pieces of it. One of which is the language itself, just like the raw text and all the libraries and all that kind of stuff. And we evaluate that in different kinds of ways to make it easier. But another is, very recently, we've been working toward visualization of the technology. Now, this is really hard to make accessible, so it's taken us a couple of years to do it. For example, are you familiar with Unity 3D? You ever heard of this?
Mm-hmm.
So for anybody listening that hasn't, Unity 3 is like a programming environment that involves 2D and 3D graphics. Well, how do you make that accessible? Well, we've solved that problem. And we have a version that's totally blind accessible and to other disabilities that allows you to do 2D and 3D gaming and all sorts of cool stuff inside of Quorum. That will come out in July. But in any case, if you want things like blocks or visualizations on top of programming languages to be accessible, you need to do that. And so when we eventually go in and add that kind of support to Quorum, we have to do the accessibility side first, so it takes a little while. But for the language, really what it is, it's a programming language where a group of scholars, not just me, but people outside of my research group, have been obsessively running studies on anything you can think of to try to make the language easier to understand. If you have loops in a normal language, that would be this for left paren int equals 0 semicolon type stuff. In Quorum, it would be repeat 10 times. And why is it those specific words? It's because we have survey data on the word choices. We have randomized controlled trials comparing it to other programming languages. And we often compare those across groups. Probably the most famous one is our placebo study. I don't know if you know that one.
No.
So in 2013, we had this idea for a study. We were trying to think of like, how would you compare programming languages and what would be the baseline? Like, for example, in the medical sciences, they often use placebos, which are things like sugar pills. And then we compare against placebo to kind of give like a comparison across a set of medicines. Like if a placebo works in a certain percentage of the time, or works is a rough word, but you get my idea, then you're comparing across. But for a programming language, what's a placebo?
Right.
So what we did was we took Quorum, we ripped out all the symbols, and then I had my student mostly laughing, rolling electronic dice and randomly choosing the symbols that go in the programming language. So like they're awful. They're absolutely horrifically bad. It's not repeat. It's like left slash. So you got like left slash pound, colon, left brace for no reason, and then like a @ symbol. And students just have to figure out that that means repeat 10 times, right? So very hard to use. And you might think, cool, we got a baseline, but that seems like ridiculously unfair until we ran the study. And it turns out Perl and Java don't beat it.
Really?
And when I say don't beat in statistics usually means two things. One is it means it doesn't find a statistically significant difference between that and the group, but also crucially, it means that even if there is a difference and you could find it at larger sample sizes, it means that it's inevitably pretty small. The question then is, why on earth would that be true? And the hypothesis that we generally have is that the word choices suck.
Yeah.
The word for doesn't mean anything to a novice. And a lot of these little braces, they have weird effects that like we wouldn't have expected. Like for example, if you have the left brace inside of a programming language, like usually it's match braces, turns out novices get the left brace wrong more often than the right one. Why? I don't know, but they do. And so oftentimes in programming languages, when we design Quorum, we use that statistical data and then we make directed decisions about which things we leave in and out. So for example, an if statement in Quorum doesn't have matching parentheses because it's one of the most common errors. And this has been shown in a ton of studies since, but our data showed it as well in 2013. Neil Brown's data in the UK shows it. Brett Becker's data shows it. Paul Denny's data shows it. I mean, it's just the general consensus from a variety of programming languages shows that that's true, so we leave it out. If the left brace is more likely to be screwed up in something like a function than the right, the left brace goes away. And it turns out that works pretty well. Or like if you have an equal sign, like in programming languages, often it's double equal to imply equality.
Equivalent, yeah.
Yeah, and it turns out that if you have a single equal, it increases a novice's ability to use that in the context of an if statement by 800%.
Wow.
Yeah, I know. That's what I said when we saw the data too. And in fact, in the studies, we then go in and use assignment and equality tests right next to each other to see if we can screw up a novice, and it doesn't happen. Like novices can figure it out based on context. The point is like you can use all that very strategically to define programming languages where you've really thought it through. You've gathered the data, you've thought it through, you've done experiments, you've replicated those experiments, you have survey data on the words and symbols, and then you've put that all in so that people can kind of use it a little bit more effectively. And then every release we do on Quorum, we work with outside scholars that are doing different studies, sometimes to disprove us and sometimes they're right. In addition, we keep doing internal studies as well to make slow incremental changes so that hopefully in like 10, 20, 50, 100 years, programming languages are much more condensed in terms of how much garbage is in them. Because right now there's a lot of garbage.
Right. I'm curious in the placebo study. So I proposed to my wife by modifying the game Minecraft, which used Java. So I've used that, but I haven't used Perl. I'm wondering if you found significant differences between lower level versus higher level languages compared to the placebo.
Right. So we didn't test that in that study, but the reason that both perform badly is actually because they have a lot of syntax in common.
Okay.
The reason where they tend to screw up is actually the same across where they're the same. And in fact, in languages that did slightly better than placebo, like Python did slightly better, it actually, where Python does badly is the same places where it matches the syntax for Python and Perl. And the reason is they use the same words and symbols, right? It just has a colon at the end instead of a brace and a match and stuff like that. So the reason why Python does slightly better is actually accidental. They still have a lot of the cruft from the 60s and 70s that didn't get rid of, but they have a couple decisions that made a small difference. And in fact, in those original studies, Quorum did better than Chance, but it did pretty badly too in a lot of ways. And we made a ton of changes since 2013 that are based on that evidence from that study and many others.
That's great. Yeah, in my coding classes, the kids had the opportunity to pick from several different languages. And one of the things that I noticed is it was easier for kids to go from a syntax-heavy language to a syntax-light language, like JavaScript to Ruby. But going the other way around, it was much more difficult because they were used to this like clear, easy to understand, quick to write, didn't have to worry about semicolons. And then when you go to JavaScript, it was like, wait, I have to add in all this other crud that I'm not used to. So they were not able to do as well with that.
Yeah, I don't have evidence on transfer of learning in both directions, but that might be true that there is different effects going either way. That wouldn't surprise me. And it's interesting you mentioned Ruby too, because a lot of what we found in those original studies as to how to make Quorum better, we actually stole from Ruby because they had some parts of the language where they did really well, like leaving off the parentheses and stuff like that. And that did really well in those studies. On the other hand, interestingly, because the whole field was non-evidence-based for such a long time, most languages make certain mistakes that they probably don't know they're making. Ruby's a good example. Ruby has dynamic typing, so does JavaScript. And it turns out dynamic typing, which is this idea that I don't tell you what the type is, I don't force you to write it. Well, it turns out that in languages like Ruby, because they have dynamic typing, that actually significantly lowers your productivity for people, I think it's past year 3 of experience level in college. At the beginning, students do have a negative impact, and it's like really small, but it goes away quickly. And we even know why it happens. The reason is because if you videotape programmers, basically what you observe is that when it's dynamically typed, if you want to call a function, You got to know what to call it with.
Right.
But the problem is you don't know what to pass. So what you observe is developers jump to the function, try to figure out what to pass to it, and then they jump back. And guess what? That takes time and therefore productivity lost.
And to hopefully clarify for people who aren't familiar with it, so like one example is Khan Academy's JavaScript. They use var as a substitute for any kind of type of data. But instead of using something like var, you might say int for integer or dub for double, or say a string or whatever to clarify in advance. I'm going to pass text, or I'm going to pass an integer that has decimal points or doesn't have decimal points, etc.
Yeah, that's exactly right. And it turns out that that VAR type approach actually lowers people's productivity a substantial amount.
That is absolutely fascinating.
I think actually now that effect of dynamic versus document, I think it's actually the most well-studied and replicated in probably all of computer science. Off the top of my head, I want to say somewhere between 10 and 20 randomized controlled trials on that topic now, and they pretty consistently show the same effect under different contexts, with and without code completion, in and out of an IDE, under this condition, that condition. It's kind of funny, like it used to be, we used to debate that in computer science a lot, but I feel like that's a solved problem now. I mean, there's more to learn, and there's probably contexts under which, so I have to put my scientist hat on for a minute and say there are caveats, and there are. But at the same time, like, if you want to say the other direction now, you got to provide the data and show us the evidence so we can see what conditions you're testing.
I'm wondering, going back to Quorum, can you describe, so I was on the webinar that you did a couple of weeks ago. So I'm wondering if you could describe in particular the positionality of the camera. That was particularly fascinating to me, how you had to think of, when looking at an object, how close or far away from you are from that object, what the distance is, and then even possibly discuss how you sonify an environment or a landscape by like kind of panning through it and playing some of the different sounds to get a picture of exactly what is displayed on the screen.
Yeah, okay. So just to provide anybody that's reading some context if they didn't hear that webinar, and we'll have a link to that at some point.
I'll put that in the show notes whenever it goes up.
In any case, so to provide context to people listening, what we've invented is we've been trying to figure out a way that we can make it so that kids that have disabilities, but even including blindness, can create games that are highly visual in nature. And there's a couple of reasons why we want to do that. And I always have to say this first, just because that sounds like, why would you do that? Of course, a blind child's not going to make a 3D game. That doesn't make any sense. But actually, there's a couple of reasons. Number one is, again, in high school, if a kid is in a class with 3D programming, it's illegal to exclude them if it's required that they take the class. You can't do that. So that's number one. But number two as well, like, I just got this hunch that if we can make that accessible, we're going to learn all sorts of weird, neat, interesting things. But so far, what we've built is we have an environment and we've tricked it to be able to be usable using technologies like screen readers, which talk to you and give you sounds related to what's in an environment. Now, how that works on a technical level is ridiculously complicated. And unless you want me to, I won't go into it. But the short and skinny is that trying to make animation loops and all this kind of stuff talk to screen readers is challenging. It took us years to figure out how to do it in such a way that it would work seamlessly. So what we have now is that we have like cameras on the screen that are in a 3D environment. There's all sorts of 3D components like boxes or spheres or things like that. So the question that I think you're getting at, Jared, is like, how does that work in terms of like what the user interface is? So like, if I have a camera and I'm looking at a 3D landscape, well, how do I describe that? And I think what we've learned so far in limited user testing and by trying it ourselves with screen readers, because we haven't finished our beta tests yet with actual blind users or other disabilities, is that so far as we can tell, the most crucial thing that you want when you're talking about making 3D things accessible is actually not the gestalt, like trying to describe the whole scene at once. It's being able to know your context, which is classically called the where am I problem in disabilities work. It's sort of like, where do I exist in this environment? But in addition, being able to interact with the things that you're working with. So I'll give you an example. If I'm like building a 3D model of an ogre and I'm blind and I can't see it, I might want to know whether the ogre, which is just one model in a giant landscape, has the focus. And I might want to know that as a whole. But once I'm on the model, I might want to know things like, how many parts does this ogre have at a high level? And it might be the arms and the legs and the head. So I want to be able to query that and start to break it down. And then I want to be able to navigate those things so that I can get information about what those are. And then I can start to drill down mathematically or in some other way. So now that's not always easy. Like if you had a castle and it had, let's just say 10 million triangles, you need to basically figure out how to combine that down into higher level items so that they can be navigated, and then allow drill downs so that you can manipulate individual pieces. And how exactly that ends up when the tool is done by, at least the first version of that part is done by the summer, will kind of be a user testing thing as we kind of try it with people. But my suspicion is that we're going to have lots of like drill down here and then go there, query the camera, or query where you are around you, or what's around me right now, or how many things are in front of me. Stuff like that is where I suspect the direction will go as we kind of test it with people and they say, oh God, why'd you do it that way? Which is what I expect to happen the first time.
And you mentioned animation. I'm curious how you would account for describing animation when there are multiple parts going on simultaneously. Is it like different pitches or textures in the voices, or?
That's a great question. Okay, so the first thing to know about animation with screen reader technologies is that making them work is like an insane challenge for reasons that have nothing to do with the user interface. And I'll describe that very briefly just to kind of give people sort of understanding. Notably, if I have in an environment like Windows, Windows uses something called the Windows message pump to get information back and forth to a computer program, right? And all this is like key presses and like mouse clicks and stuff like that. But the Windows message pump, when you're working inside of an animation library, is tied to the frame rate in certain ways, depending on how you pump it out. So think about that for a second. I get a key press, it goes on a frame, ta-da. Normally for animation, good. That's exactly how it should work. But the problem is screen reading technologies don't work that way. What they do is they get a key press and then they go through a dance with the application to try to make sure that it's querying for information at a particular time. So point being, if I press like down on the keyboard and I'm in a text editor, that might actually send back a few hundred, and I mean 100, requests to the application to gather like, where's the cursor? What is it doing? Are there any annotations here? Are there spelling errors when I'm at, or whatever it's doing, right? And so what we learned very quickly when trying to integrate an animation loop is that we have to do these like nasty equations behind the scenes to sort of force pumping in bizarre ways that don't limit the frame rate too much, although just a smidge, and that's unavoidable, but also allow it to be accessible so that you can get information back and forth to the screen reader without delays. Because if you had one request per screen reader per delay and you have a 30 frames per second, then one down arrow on the keyboard, all of a sudden you got 30 seconds until you got your little animation. So once we solved that, we then realized that if you had multiple things animating at once, you're not going to be able to understand it all at the same time. So what we then do is we have a system where you can provide information to the screen reader at strategic times. And this is done in a couple ways. One of which is that there are certain events that get fired as animations trigger that provide information to our screen reader architecture that then selectively chooses whether or not it sends information to the system. So that's number one. A good example of that would be if you press a button, you want it to click and you want the screen reader to know that. And like that is technically an animation with lots of frames doing all sorts of stuff, but the crucial information you need is the click, not the fact that it's like, flashing or whatever it's doing. And same with 3D animation too. Like if I'm rotating something, I'm not going to provide screen reader information on every step of that rotation, but I might give it only when it's done or maybe along the way or stuff like that. And those have to be kind of tuned with user testing to make sure we kind of get it right and it feels good. Normally when we use it, it's pretty easy to tell kind of when those should trigger. But then the last thing is screen readers, while they have good mechanisms for connecting into things like text editors and stuff, they just don't connect at all to 3D engines. So there's some things that we have to present to the user that don't follow a standard Windows event infrastructure. So for those, we have this little thing that we call a notify. And a notify is an event that doesn't match to an event, but forces the screen reader to talk in appropriate ways at appropriate times. An example of that might be when I'm using a camera. One of the things we found pretty quickly is that if we try using a screen reader blind, I want to query it for all sorts of information, like where am I? What are my coordinates? What's around me? What's in front of me? What's in my frustum? What's in my, if I zoom out, what's far, stuff like that.
Yeah.
And so the way that we do that is we use a series of accessibility notifiers. They're not events, really. They give the screen reader context about a certain querying condition, and that tells the screen reader, oh, I need to find some information, and then it goes and finds it, and you're good to go. So it's really tricky. Like, it's not one thing.
Right.
It involves a series of technologies, but it's possible. You just have to be kind of judicious, and you always have to test it with people because it's real easy to get it wrong or make it just not feel good.
How do you recommend CS educators use Quorum in the classroom? Because somebody might be listening to this and go, okay, awesome, I have an option for children who are blind or hard of sight, but what about all the other kids? Would they be able to use it as well?
Yeah. So there's a couple things going on in the Quorum project. First is last year, I think that the number of users on our website for Quorum was in the ballpark of 80,000, something like that, which is a lot more than students with blindness, right? Like, it's not just blind kids that use this stuff. It's a lot of schools in general use it. I don't always know the ways they use it because they don't mail us what they're doing in the classroom and stuff. But I would say the most common thing that I see people doing online on analytics and stuff is using it for computer science principles. Because we have a mapping of our curriculum to code.orgs, which they kindly gave us permission to do, except that all the tools and techniques are accessible. I will say that in the future, what I suspect people will use for it is we'll probably add a block visualization mode on, so that if you're in a typical school and you're wanting to do whatever you feel like doing and you're used to that kind of thing, you can just do whatever you want normally, but it's also accessible. So over time, my suspicion is that Quorum will follow all the same visual standards that some of the sort of fun kids tools do, but at the same time will remain accessible so you can use it just for whatever. The last thing I'll mention is teachers in the classroom that use Quorum use it for a lot of different stuff that I wouldn't expect. So like, I know there's schools in Maryland that use it for Lego robot competitions. There's a lot of schools that use it for game programming, like 2D or 3D games under all sorts of things. There's people that use our digital signals processing libraries to write like little audio things. There's people that just make audio games that like plant 3D sounds all over the environment and then run around with them and stuff. There's things like that. There's a group of people in mostly Wisconsin that use Quorum to connect to robotic telescopes. And then they send back images from these telescopes and do analysis on them, something like that. So lots of stuff, actually. Quorum's really powerful for doing all sorts of like even non-kiddie style things. I just don't know all the details about how everybody uses it, but those are some examples of what people do right now.
So while you're talking about Quorum and like navigating a 3D environment, I'm curious, have you looked into accessibility issues in relation to AR and VR?
So we've thought about it, but we haven't done anything with it yet. It turns out there is a way in our environment to connect AR and VR libraries up to our existing stack. In fact, it turns out to be relatively easy to do. However, we haven't like bought the devices to test with it. And I don't know how the accessibility works on those devices. Like, for example, does an Oculus have screen reader support? I'm guessing no, but we haven't looked into it. So I think there's actually a lot of opportunities there for lots of people. Even if you can't see, man, the things that you can do if you can turn your head and observe it is really powerful. But I haven't done much. I haven't done anything with that. I think there's real opportunity in Quorum or out of it.
Yeah, and I'm slowly learning Japanese, and so like each weekend somebody comes over and she's a native Japanese speaker, and we kind of like, she helps me out with learning how to do that. And one of the things she showed me, I didn't realize in Google Translate you could actually pull up your camera with that and it'll translate an image. Like, you hold up a piece of paper with something in Japanese and it'll on your screen make it into English.
Oh, wow.
So I'm wondering if there are applications of that in relation to screen readers with an AR. So if you potentially had on some kind of a headset that allowed you to basically audibly translate the visual environment as you're going through it.
I hadn't really thought about that, but that makes complete sense. I can imagine that being highly possible. That sounds like I can imagine that'd be really cool. Like maybe you have a pair of glasses or something that has a little camera on them. And as you're walking around as a blind person, you can see, and it says water closet if you're in Europe, or bathroom if you're in Japan or something like that. Even though it might be in a different language, that doesn't matter because it automatically translates.
So I'm wondering if you could wave your magic wand and instantly make CS and CS education more accessible, what kind of changes would you make?
In terms of accessibility, there's really two that immediately come to mind. One is accessibility infrastructures really shouldn't be different across programming languages and across platforms. And that particular issue sounds like it's minor because we just deal with this fact. But the truth of the matter is the programming language wars, where every company makes its own language with its own platforms and own APIs, has caused serious damage to our discipline. And it's like triply so for accessibility, because like you go in and build accessibility support into Windows, sorry, it works nowhere else because the code is incompatible. And also, with some applications, like all of us just accept, well, if I'm making a user interface in Java, it's different than Swift. That shouldn't be true either. The languages should be more consolidated than that. There should be like an API that's across languages, but never mind that. But for accessibility, it's even worse because the accessibility infrastructures usually are kind of broken on each platform. So like you go off and use Microsoft's UIA providers, and it has just a million quirks because it doesn't work in certain ways under certain contexts. Like if you use multi-threading in JAWS, it breaks, but not with NVDA. But if you go onto other platforms like Android or Windows, I mean, Apple, it's completely different. Like literally you have to throw your code away and start over. And that's a huge problem because those accessibility infrastructures are massively different and they're broken in their own ways too. So it's like, you need almost like a team of 20 to really get accessibility support everywhere. And most teams just aren't that big. And that's just the accessibility part before you even touch the problem you're trying to work on. So I wish that the companies would get it together and make a unified accessibility infrastructure for all platforms and all languages so that it could be more unified everywhere and you write it once and everybody can map to it. But that's pipe dreamy. I mean, like the companies aren't doing that in any way right now. So, and in addition, the companies too, they don't have a vested interest because like if Swift makes Apple's stuff and they make a custom language and they get schools to use it, then you're boxed into their platform.
Right.
And so then developers are more likely to build stuff for their things that gets more apps. And so there's a commercial interest. Personally, I suspect long-term the government will have to step in to sort of start to fix some of these issues. But how to do that without being heavy-handed and to make it actually reasonable and equitable is a tricky thing. It's not simple at all.
Yeah, I'm a Windows, Android kind of user and taught Swift in my classes because we had a Mac lab and I love the language, but I can't use it now because I no longer have a Mac.
Yeah.
It's unfortunate.
And that's just the platform, but like it's a legitimate issue. And if you have, Windows and you're doing accessibility, well, you can't do that on Mac either. I mean, maybe there's a way to get around some of it, but we haven't been able to figure that out.
I'm curious, in your CS classes that you teach, do you use Quorum only as the language and platform, or if you use others, how do you consider the various affordances and constraints when you're picking a language or a platform for your class?
Oh, that's a good question. So I always actually feel uncomfortable pushing my own work onto my students.
Yeah.
I wouldn't say that it's unethical. Like legally, there's no mandate about it. But it just feels like, I want my students to feel able to explore and like be able to do kind of what are interested in, and that's okay. But in my classes, I usually teach like upper division stuff. So they're project based. Students kind of get to choose stuff. So I almost always have a student team that's at least willing to try it. And then, not by mandate, but by choice. And so some of the more popular ones are like building like games that are accessible and stuff like that. But even then, it's not always Quorum. So I had a few years ago, I had a team try to make World of Warcraft accessible. I'm like, that is really hard. They had 50 accounts banned by Blizzard. They were trying to automate things to make it accessible. They weren't trying to cheat.
Right.
Blizzard didn't quite see it that way because they couldn't have known. All the time that we'll make a role-playing game, try to make it accessible, and they usually use Quorum there because there's libraries built in to make it accessible, so it's a lot easier than trying to do it in Unity where it would be a nightmare to try to make it accessible. My own personal balance, which other professors might have their own way, is I never mandate it for students. I let them choose whatever they want, but oftentimes since students know that I do this kind of stuff, I do work with some of them on Quorum stuff, and that can sometimes lead to some pretty fun projects.
Yeah, I know it's a little weird kind of asking people to use something that you've created. Like having taught classes where I'm like, hey, I wrote this publication on this thing, but here are some other publications sort of related to this topic.
Again, it's not like it's unethical. It's fine. There's nothing wrong with it. It's a legit product that you can use and stuff.
Right.
But it also feels like, am I just too close to it? Am I pushing something? And maybe that's wrong. Maybe it's fine and I shouldn't even think about it. But I always second guess myself. And maybe it's an imposter syndrome. I don't know. Maybe I should, but I like to let students choose.
Yeah, I agree with that sentiment. Having had some professors that would push their books on you and then you never end up using it in your class.
Yeah, exactly. Right. It's stuff like that. It just feels like it's not necessarily malicious. It's just,
Thankfully, those were professors outside of my major. They're just like some of the general studies classes. So I'm curious, working in higher education and research in particular is a pretty demanding job in terms of like some of the pressures, in terms of output for publications, presentations, other works and whatnot. So how do you kind of take care of yourself or try and stave off some of the burnout that comes with jobs like these?
Oh, that's a good question. I don't know if anybody's ever asked me that before. You're right, it is challenging. Because academia, there's always these phrases like publish or perish, and they are true. If you don't publish, you don't get to keep your job, at least until you get tenure. And then there's a lot of protection. But, for me, I would actually say I had a better balance after I got tenure than before. And that's probably pretty typical. But, in my own case, I am careful about my health, number one. I exercise regularly. I watch my calories and try to keep myself physically fit. So that's important to me. And I don't have direct evidence that helps, but I feel like it helps me. Mm-hmm. That's one thing. But then number two, I also feel like academics should, especially once they have tenure, when you're still trying to keep your job, you kind of don't have as much choice, because you're trying to prove yourself. But once you do, I also feel like academics should take a step back and realize that a lot of the academic metrics that universities use are stupid. Like, for example, if you wrote an academic paper and you said, I think we should hire and fire academics based purely on the number of papers that they publish, you would get a rejection letter. Because that's stupid. But in tenure and promotion guidelines, that's often what we actually do in practice, right? Like there's a lot of universities, they don't even read the papers that their academics put in. They just say, well, you published 6 in this time. Good job. You get to keep your job. That just makes absolutely no sense. It's totally ludicrous. And so I think part of my own sanity is I've come to the conclusion that some of it I'm just going to ignore. And I will publish enough that the admins will keep off my back and stuff like that. And I like to publish anyway, so I guess there's that advantage. But I'm also going to spend a lot of time doing what I love. And to me, that's programming. And so I spend a lot of my days thinking of how am I going to hack together this thing to make 3D work for a blind kid? My colleagues are supportive, but if they didn't like it, I'm fine with that. Then give me a bad evaluation. Fortunately, I'm lucky in that we've gotten awards and, all sorts of stuff and, people are sort of okay. But at the same time, some of it too is you have to kind of be willing to speak out a little and remind your colleagues that some of these academic metrics are really not evidence-based. They're just kind of we chose paper counts because the admins can count them easily. In academia, it's funny. They always talk about teaching, research, and service, right? And it's funny, with research, we have these absurd metrics. For teaching, we often use teaching evaluations, and mine are very high, but there's lots of issues with them having gender bias they're just not really good. Mm-hmm. And then service, we don't take any metrics. And so therefore, somehow people just ignore service and it's just not taken seriously. And it is really weird that we evaluate academia this way. And it should probably change if we want to keep our own sanity. As one academic, I only have so much control of such things. Anyway, so for me, it's health stuff and then kind of ignoring some of the flub a little bit.
That makes sense. And what do you wish there was more research on that could inform your own practices?
Well, this is my own bias talking, but I really want 10,000 more papers on the human factors impact of programming languages. Look, this impacts more than $300 billion a year in wages in the US alone. It's a huge deal. For students, it's a monstrosity. And then in K through 12 computer science, think about this. Right now, we've got these things like computer science principles, right? Which I think is generally actually a pretty well thought through standard. However, because there's no language attached to it and computer scientists cannot seem to agree that 4 is a bad word choice, haven't 30 or 40 years, we're in this weird situation where you might go to one school, you're learning a notation about programming. The school right over uses one different. And the problem is that's absurd. In math, we don't do that. If you have an integral, we use the integral symbol. There are alternative notations. If you want to use the plus symbol in math, everybody agrees what the freaking plus symbol means. But in computer science, we don't. Not even the plus do people agree on what that means. In C++, it means something different in Java, and that's stupid. We need to get rid of that. So in my magic wand waving way, what I want a lot more human factors research on that, because I think if we can sort a lot of that stuff out and rule out a lot of these bad decisions that language designers have made, we can start to construct products that are based on sound evidence and then get them adopted slowly over time, get rid of some of these languages like, maybe like Perl that aren't very well constructed in terms of their human factors impact, slowly let them die and let languages that are using evidence that are slowly making improvements over time, let those slowly get adopted. That's one reason why on Quorum we focus on adoption as well. That's why when we first started, we had 4 kids. And then now it's like more than 80,000. I don't want it to grow too fast. And I don't want it to be the only option out there because Quorum still has a lot of areas where we need more data, to say the least. Especially right now, we're redoing all our compiler error messages because there's good, strong data we need to. But in any case, I think that would probably make a big difference because this language wars problem has been systemic, huge problems for our discipline, and we don't really talk about it that much. We just kind of accept that it's this big, nasty mess.
Yeah, and in the K-12, in particular in the younger grade levels, it is based more on how shiny it looks and the marketing that's behind it rather than the evidence that supports the learning, hopefully, that's involved with whatever platform is being used or language.
It really is, right? Like, I mean, to a certain extent, we all want students to be engaged. And so, like, I'm all for, like, making little animations and doing this kind of stuff. That's all good. I get it. I mean, like, I don't want to just have kids use a console. That's pretty damn boring. But on the other hand, too, like, the data does matter. And even if, like, that stuff is shiny, the fact that there's a bazillion different products and kids are all learning different things, you'd think that, like, I don't know, in my magical dream world, which, maybe in like 10 lifetimes from now, what I would really like to see is that there's one standardized syntax for languages that is like a bare minimum. And then any language that out there, and it's super evidence-based, there's hardcore data, people have tried to refute the evidence countless times, blah, blah, blah. And then any language that exists, they can innovate on top of that standard, but they use that standard for basic things like looping. Like everybody uses repeat 10 times because it just makes damn common sense, right? And then the standard libraries are all built on the common part, not the experimental part, thereby making it so we can get to closer standards over time, over like a 50-year century, so that maybe we can get rid of some of these problems before the next 3 or 4 generations go by. Because like the problem is, if we don't do anything, kids 3 generations from now are going to have the same damn problem for the same reason. It's just not right. It's going to screw up generations of kids if we don't fix it. So I don't know, maybe I'm being pedantic, but that's my view.
No, I like it. I mean, in general, I like multi-perspectival approaches with most things in life, but we need to have those perspectives built off of some kind of valid research that supports the claims that are typically marketed out with it.
Yeah, exactly. Well, and in other disciplines too, to my brain, it feels like there's sort of a core and then there's an experimental part where we tweak. Like, for example, generally in schools, teachers aren't going to change the meaning of the plus symbol, right? Because like that's just part of our standard. We accept that that symbol means one thing, or at least in K through 12 setting. If you want to make some innovative mathematics, you can use your own crazy symbols. But if that becomes standard where everybody's learning about it, then the textbooks try to get some kind of normal notation for it. And we try to kind of boil it down so everybody's doing it. We need that in computer science too. Like if we're talking about looping, we should try to like use the same symbols and terminology so that any kid, no matter what school they're at, can start to like, communicate with each other. It just feels like it'll help society, Like, I mean, think about this. I don't have any evidence of this, but I wonder if you were to take the number of hours work from building the standard libraries that do the same thing in every programming language that exists, lists, arrays, games, all this kind of stuff, how much money have we blown down the drain by rebuilding the same sort of library? I mean, it's got to be one of the most massive duplications of effort in human history to do that. And like, we don't talk about that in computer science. We're just like, try Python, it's great. Whatever language you want to pick.
And the irony of that in relation to CS in particular is not lost on me in the fact that it's like, oh, why don't I just find somebody else's code that will do this, automate this thing that make my life a whole lot easier.
Exactly. I've been there too. Absolutely. It's just the nature of the beast sometimes, right? Because we still live in the society we live in. I mean, like we can't change it immediately.
Looking at your Google Scholar profile, there's a lot of publications on there and in your CV. I'm curious if there's in particular that you really wish more people read or kind of understood.
the study on that placebo study. That's probably the one that's the most well known. I don't know if I have one in particular where I'm like, this is the one thou shalt know. But I feel like the broader theme of the work that we've been doing is to try to get at these broader like language design type issues. And I wish that people had not necessarily one of the publications, but what I wish, these textbooks for like principles of programming languages, they were talking about like, they make a crap ton of claims like, this thing is better than that thing and stuff like that. And I wish those would be rewritten and like thrown in the trash. And then we would make a new generation of those textbooks where instead of just talking about like, this is what scoping is, and then also here's the impact on people that are working when they use these things. And here's the impact on students. Like, for example, when students leave a class on principles of programming, shouldn't they actually know that differences in programming languages impact people very strongly? I mean, like, isn't that a fundamental principle of programming languages? All we really do is just say, here's a smattering of languages that exist, and like, you can try them all, and then that's it. Somehow they're not better or worse, they're just different.
Right.
Which is crap, because it's not true at all. Or like this other common phrase you hear in classes like that is, you just have to choose the right tool for the job, right? And like, that's just such a ridiculous, nonsensical statement. Yes, if you're on Apple, you only have so many choices for what languages you use, but that doesn't make it the right tool. It means the only one that you can use because of either license agreements or something else. It's not quite the same. So, I mean, to me, I wish these principles programming books would be rewritten completely, and that inside of them would contain the smattering of evidence across a lot of scholars on what we know now about stuff, so that when students leave school, they actually have some background in like what's going on in the myriad of research groups that are finding these particular effects in the last 10 years or so.
Yeah, so even though the last few years I've been working full-time in CS education, like I've mentioned outside of this interview, that all my degrees are in music education, so I'm technically coming from it from an outside perspective. And in music education and other areas within education, there's a lot more critical discussion on the discourse that is going on in those fields. And I think that is something that's kind of like lacking in CS education in particular, is we need to have more conversations about some of the things that you're talking about, that no, these are not equally as good. They're better or worse in certain ways than others, and we need to kind of talk about those things.
I think so too. I don't know what the actual debates are in music education. Can I ask, what are they?
Yeah, so the biggest debate right now is the debate about whether large ensembles are anachronistic. So yes, they provide some awesome opportunities for people to create music, but what opportunities are there for people to continue that music making once they finish their K-12 tenure?
Oh man, isn't that the truth? That's interesting.
So that is like one of the biggest things. And there's a huge divide among the field where people are like, no, I'm 100% for large ensembles. And other people are like, no, we need to just burn that down and just start with like popular music making today's, like DJing and rapping or whatever, and do only that. And then there's like people who are like, well, they both have their places. And so that's a large one.
That's pretty interesting, especially given that, and your experience might be different, but when I was doing my music singular degree, just the one, a lot of what you do learn does feel really old, right?
Mm-hmm.
There's a thing called counterpoint, and it has to do with like when notes are sorted together and how they're kind of linked up and stuff like that, what that ends up sounding. But if you take a class on actual counterpoint, the actual theories are from this guy named Fuchs, if I recall, Fuchsian counterpoint, they call it. It's from like the 1600s. And their theories really haven't been updated in, 400, 500 years, right? 400, I forget exactly. And so it is funny that music education did feel like it needed more evidence to sort of update itself as well. That's a whole other lifetime of scholarly work, I suppose.
I had run into a lot of conflict through my degree in that the last course I ended up taking was a Russian music theory course for my PhD, and it had absolutely nothing to do with anything I was interested in scholarship-wise. It had no sway on anything I was doing, but I had to do it because it was a music degree, technically, in a music school, and the electronic studio courses that I took would not count as music theory. So I took a class that was about creating music software through Max MSP, which is a graphical programming language, and that would not count as music theory. And then even though it was a music theory course housed in the music theory department, so like they even had that divide where, oh, if it's anything electronic, sorry, that doesn't count as real music theory, doing air quotes there. You need to do this other thing that is completely irrelevant to whatever it is you're doing.
That is crazy because, so I used to program in, I don't even know if it's still around anymore, a programming language called Super Collider.
Yeah.
Yes, so it's like kind of a text-based version of Max MSP. I think Max is a lot easier to use, frankly, but nonetheless, Supercollider is what we were kind of messing with. And it is very theoretical, right? Like you need to know some math, you need to know how all these pieces link together. There's these weird gens and they link up. I mean, like that they wouldn't count that as theory is just crazy.
Yeah, I felt the same way. That's why I kept pushing off that course, because I was like, maybe if I petition it, they'll eventually count these as an actual music theory course, but they wouldn't. So that was the last thing I had to do.
That is so funny. It does feel like that. It's like that's legitimately theoretical in nature, but clearly not, I guess.
Do you have any questions for myself or to the field at large?
Nothing immediately comes to mind. I will say, though, for people that are interested, try to make your stuff accessible. It's good for your students. There's a lot of people that have disability challenges or whatever, and it does people good. It's a good way to not only feel good, but like it does good. It's a good thing. It's for the betterment of society. So if you can, give it a shot.
Where might people go to connect with you and the organizations you work with?
They can email me at my normal university email, which is online. If you're interested in Quorum stuff, there's a Quorum mailing list, and that's linked on the Quorum website, which is at quorumlanguage.com. If you're interested in accessibility, the name of our grants that we do, we call it Access CS for All, and that's Googleable for sure, but I can toss you a link for some of these things so people can get them on the site or whatever. Access CS for All has a number of various mailing lists for different kinds of interests that people have. They're relatively low traffic on purpose so we don't bombard people. If you want to get even more involved, we have regular meetings for developers related to accessibility, for people that sort of want more or just want to learn more. Like, for example, I think you actually went to our most recent webinar, which was on 3D technologies that are blinding.
Yeah, and I think I became aware of that webinar because of being on the newsletter, in the mailing list, rather.
Oh, okay, cool, yeah. And there's others, too, that we have on that, too. I think we had Stephanie Ludi, who does awesome work in Texas on accessibility. And I think we had someone from Google that was doing some cool accessibility stuff. Lots of people like that.
And with that, that concludes this week's episode of the CSK8 podcast. I hope you enjoyed listening to this episode as much as I enjoyed interviewing Stefik. Just as a friendly reminder, I'd really appreciate it if you would share this with somebody else or simply write a review on whatever platform you're listening to this on. Helps other people find it. Speaking of finding stuff, friendly reminder, you can find the show notes in the description that you're listening to this on or by visiting jaredoleary.com. Stay tuned next week for another Unpacking Scholarship episode, and 2 weeks from now, you will get another interview. Until then, I hope you all have a wonderful week.